All right, so for this problem, we've got 1/2 square root of x minus 2 plus 2. So as with all problems, I'm going to start with the parent function, square root of x. And I'm going to plug in 0, 1, 4, and 9. Remember, I plug in 0, 1, 4, and 9 because they're perfect squares, and they give me integers, right? The square root of 4 is 2, right? If I were to plug in 3, that'd be square root of 3, and nobody wants to graph square root of 3. So that's why we start with these points. It'll always be these points, because the parent function, the function of this problem, is square root of x, right? So what we can do is we can look at what's happening to our x's. So under the radical is what's happening to our x's, and we only have one thing happening, right? We have that we're x minus 2. So we don't have to worry about order in this case, we just have to worry about operation. And remember, for under the radical inside the function, we always do opposite operation. So I'm going to add 2 to all of my x's. Okay, now for my y's, the things outside of the function, I've got two things happening. I'm multiplying by 1/2 and adding 2. But remember, we always do as it says in the order it says it for y, right? Y, everything's intuitive, as you would think it would be. For x's, it's counterintuitive. So that means first we're going to multiply our y's by 1/2, because that's what it says to do, and that's in PEMDAS order. And then we'll add 2 to our y. So first, let's remake a table with adding 2 to our x's, right? When I say add 2 to our x's, I'm talking about the x coordinates, right? We're going to add 2 to all of them. So that'll become 2, 3, 6, and 11. My y's, if I multiply them all by 1/2, right? 0 times 1/2 is 0. 1 times 1/2 is 1/2. 2 times 1/2 is 1. And 3 times 1/2 is 1.5. Okay, and then last but not least, again, I don't have a second thing happening to the x's, so I don't have to do a second thing to the x's, but I'm going to add 2 to my y's. It's on the outside of the function, so it's happening to my y values, and it is adding, so we add. So my x's stay the same, 2, 3, 6, 11, and my y values are going to be added by 2, right? Shifted up 2. So 2, 2.5, 3, and 3.5. Okay, now that I have my points, I just need to plot them on my graph. I like to plot my points before I find my domain and range. You can find it algebraically if you would like. 6, 3, and 11, 3.5. So this point won't actually fit, but sometimes it does, and sometimes it can help us with the shape. Okay, so remember, my start point of my graph is always the point that 0, 0 got transformed into. So we had 0, 0, and over a series of transformations, it became 2, 2. So we know that 2, 2 is where we start, and we draw our function going through the points away from 2, 2. Now that we have it graphed, we can talk domain and range. So something you can kind of remember that should help you, it's memorization, but it's a good thing to remember, is your domain and range will always have to do with your start point, right? Your start point will always be in your domain. So in this case, we know 2 is going to be in it. But I just like to think of it visually. So I know my domain is my x values, right? My domain is my x's. So I can see my first x appears at 2, right? That's my start point. That's what I was talking about. And then it goes to the right forever. So if this is on a number line, we can think it's starting at 2 and going to positive infinity. So we would write that in interval notation as 2, infinity. We're going to use a parenthesis with infinity because you can never include infinity. And then we're going to use a bracket on 2 to show that it's included in the function. Right? It's an actual point on this graph, so it's included in our domain. Then my range, I also like to look at visually, but you can again see the starting point. It starts at 2, and then notice my function never goes below 2, right? It's never down there. It doesn't go up very quickly, right? You can see the rate it's going up is not a lot, but it is going up forever. So our range is going to be from 2 to infinity as well. All right, so for this one, we've got quite a bit going on. We actually have 4 transformations, right? We're multiplying by 2, that's a vertical stretch outside of the radical. Then under the square root, we're multiplying by 2, which is a horizontal shrink. Subtracting 10 under the radical is going to shift it to the right. And then minus 4 outside the radical is going to shift it down. So just like with the other problem, we're going to start with the parent function, square root of x, and it's going to be 0, 0, 1, 1, 4, 2, and 9, 3. And then we've got to talk about our transformation. So now this time we have 2 things under the radical, right? We have a 2x and a minus 10. Now, not only is the operation opposite, so we're going to divide by 2 and add 10, but the order we do them in is also opposite PEMDAS, right? We're doing it opposite than we normally do. So I'm going to add the 10 first, then divide by 2. So the first thing I'm going to do to my x's is add 10. The second thing I'll do to my x's, so here's my table, the next thing I would do is divide by 2. Okay, for my y's, I also have 2 things happening, but remember, we've got them outside the radical, which means not only do we do them in the order that PEMDAS would tell us, but we do the operation that it tells us. So the first thing we'll do to the y's is multiply by 2, right? Because that's what you do first. In order of operations, you do multiplication first. And then the second thing we would do is subtract 4, right? Subtraction comes next in order of operations, and again, we're using the operation that's given to us for the y values. Okay, so now it's just a matter of filling in my table. So remember, when I say that I'm adding 10 to my x's, that means I'm adding 10 to all my x coordinates. So 10, 11, 14, and 19. And then when I say that I am, multiplying my y coordinates by 2, that means I'm taking these guys and multiplying them by 2. So 0, 2, 4, 6. Okay, so I applied my first set of transformations. Then I'll do my horizontal shrink right here by dividing my x values by 2. So 5 divided by 2 is 10. 11 divided by 2 is 5.5. 14 divided by 2 is 7. And 19 divided by 2 is 9.5. Okay. Then I'll take my y's, shift them all down. So we'll have negative 4. I don't know why there's 2 dots there. Negative 4. Negative 2. 0, and 2. Okay, so again, now that we've got our points and we've transformed them all, it's just a matter of plotting them. So we'll go over 5, down negative 4, over 5.5, down negative 2, over 7, that's not 7, over 7, up, down, none, over 9.5, up 1. Okay, so now we can, when we're connecting it, think about, again, as we have been, that this point was our starting point, right? A parent function, the parent function looks like that, roughly. 0, 0 is the starting point. Well, now the starting point is 5, negative 4. So I know that I start at 5, negative 4, and that's how I connect my points on my graph. And the graphing part is done. Now I just have to do domain and range. So again, it has to do with the start point. It just matters the direction it's going in. So for my domain, if we look, my x's start at 5, and then I just need to determine if they're going to the left or the right. This is going to the right forever. So on a number line, that's 5 to infinity. So we write bracket 5 to infinity. For my range, I look at it pretty similarly, but I'm going to look at my y values, right? My lowest or my highest, we're looking for the max or the min. The lowest y value in this case is -4, because then it goes up forever. So my range would be -4, infinity. So we'll do one more example because I wanted to do one where we had a reflection. So just like the other ones, we will start this off with our parent function, which will be the points 0, 0, 1, 1, 4, 2, and 9, 3. Okay, looking at our horizontal transformations, we only have 1 under the radical, right? X plus 1 is the only thing, so we don't have to worry about the order. It would happen first if there was a number being multiplied, but we don't have to worry about that because there's only a single number under the radical. So not only would we do it first, but we're going to do opposite operations. So x plus 1 under the radical tells us that we're going to take our x's and subtract 1. Okay, now with the y values, we got two things going on outside of the radical, so we have to determine which comes first. And remember, with outside of the radical things, those are happening vertically. And with vertical things, we do them the way they are, the way they say, what they say, how they say it. So this would say, if you were just multiplying this out and, simplifying, you would do 3 times first, then you would add 4. So the first thing we're going to do is multiply our y's, and let me write it like this so you don't get confused. Multiply our y's by -3. Right, now this is actually 2 transformations. This is a vertical reflection and a vertical stretch. But because we can multiply by -1 and 3 at the same time, it can be one algebra step. So let's fill those in. We'll get -1, 0, 3, 8. And then over here, we'll get 0, -3, -6, -9. Then, last but not least, we've got a plus 4 on the outside of the function. So that means it's happening to the y's. And so we do as it says. So we're going to add 4 to all our y values. That means our x's stay the same. They're still -1, 0, 3, and 8. And my y's are going to go up 4. Okay. Now it's just a matter of plotting our points. -1, 4, 0, 1, 3, -2, and this one actually fits, 8, -5. Now we've just got to connect our points, keeping in mind that our starting point is the -1, 4 point, because that's what 0, 0 got transformed into. So we will start at -1, 4, and kind of draw that through our function here. Now it's just a matter of finding domain and range, right? So our domain is going to be our x values, right? We can see from our starting point and also our graph that our function starts at -1 and then it goes to the right forever. So that's just simply going to be x we'll include -1 and have it go to infinity. Right? My range, on the other hand, is a little different than what we've seen because it starts at 4. That's where we started. That was our starting point. But then it goes down forever. Right? So it's really, really tempting to write, 4 to -infinity. Because that's how we look at it. We look at it and say, oh, it starts at 4. It goes down forever. We don't say, oh, it's, infinitely low and then it stops at 4. But really, that's what's happening because we read these things like a number line, right? From -infinity to infinity, with 4 being in here, we read left to right. So So we've got to make sure that we write this as negative infinity to 4. And we are done.